Okay, this is the last one, I promise. So this one says find the second order derivative of y squared minus xy is equal to 3. Again, we need to implicitly differentiate this. So right off the bat, though, what I notice is that we've got a term that's xy there. I know that we're going to need to do the product law, or the product rules. What I'm going to do is just right now, I'm going to write down what, like if this was f and this was g, let's figure out what f prime and g prime are. So let's write that down over on the side here. So f is equal to x. And I just thought this now. The reason why it's not negative x is because when we actually take the derivative of this, we're going to be looking at just this part. We're going to put that in brackets. So I'm just going to call it just x for now, not negative x. Hopefully that made sense. F prime is going to be equal to, well, derivative of x is just 1. G is y, and g prime is going to be, well, 1, but then remember times dy dx, and that's the thing we're going to need. Okay, so we've got that kind of figured out now. Now let's actually just take the derivative of this function, and it's implicitly differentiated. So we're going to, it's kind of like saying dy dx of the entire thing. So the first part is going to be 2y, but then don't forget, since it's a y term, it's going to be dy dx tacked onto it as well. Minus, now this is where I'm going to put in brackets and just do my product rule right here. So remember, product rule was f prime g plus f g prime. So I'm going to put that in my brackets down here. F was, or f prime, sorry, or f the derivative was 1. G was y plus f was x, and then g prime was the derivative, dy dx. Okay, and now I'm just going to clean this up because it's kind of hard to see what I need to do with this. So if when I clean this up, this turns into 2y dy dx minus y, and then minus, remember that this is distributive, so the negative up front is being multiplied by both terms, so minus, and now x dy dx is equal to, and the derivative of just 3, just a constant term, is 0. And I should have had a 0 up there too. Okay, so that's equal to 0. Now, what we want to have happen here is we want to end up with one of these guys. We want to end up with 1 dy dx in the end. So we need some way of combining those. So what we're going to do is we want to pull out a common factor. But right now, dy dx isn't common to every term here. Let's move this y over to the other side, and then it will be. So if we do that, we'll end up with 2y dy dx. Let me put like a multiply there. I'm bringing the y over, so I'm leaving it out now. So then it's still minus x dy dx is equal to y. Once I factor out dy dx, that's my next step here. That's going to look like this. So I'm going to factor out dy dx. So dy dx, open my bracket. What do I have left in each one of those terms? In this term, I still have 2y, and then minus, and in this term, I still have x. Y is still on the other side of the equation. Now, if I want dy dx on its own, I just need to divide by this entire term, right? So dy dx is equal to y over 2y minus x. And that's only our first derivative. We gotta take one more. So that was the first derivative. We need the second. And as I'm looking at this, this looks to me like we're going to use the quotient rule. So I'm going to figure out, like if we call the top f, we call the bottom g, let's figure out what f and g prime are. So let's write these over here. F is equal to y. F prime is going to be equal to 1, right? G, I messed up. Not y. Sorry. It's going to be 1. I didn't quite mess up yet. 1 and then dy dx. I thought I forgot to tack that on, but I had time. So if we move on here, we got g was equal to just that entire bottom term, 2y minus x, and g prime, it's going to be 2, that first term, right? So we're looking at the derivative of this. 2 times the derivative, dy dx, and then minus derivative of x is just 1. And remember, we're going to do the same little tricky thing where we know what this is equal to. We just found it. It's equal to this. So when we keep on going, we're going to replace those terms with what we know it actually is. So if we go on down, if we use our quotient rule and take the derivative, so now we're taking the derivative of this entire thing, right? So ddx of this entire derivative again. So we'll use our implicit differentiation, and we'll start just filling in our quotient rule formula. So f prime, we figured out, was just dy dx. So dy dx. And then times g was 2y minus x minus f was just y. G prime was 2 times the derivative, dy dx, minus 1. And this is all going to be equal to our f prime prime, second derivative. And it is all over g squared 2y minus x squared. All right. Now, like I said, we're going to replace these dy dx's with what we know they are. Dy dx is equal to y over 2y minus x. So I'm just going to put that over here just so we kind of remember. Dy dx is equal to, what did I say it was? Y over 2y minus x. So everywhere there's a dy dx, we're going to replace it with this. So let's start doing that. So this first one, we've got y over 2y minus x in place of that. And then we've got, still again, 2y minus x minus y 2. And then again, maybe I'll put this square bracket so they kind of, you know that they're the dy dx's. So then y over 2y minus x minus 1. Now we need to simplify this mess. Oh, and I keep forgetting my denominator. All over 2y minus x squared. So now, simplify this mess. I'm going to simplify this a little bit more too, and I'm going to write it in a little bit of a unique way just so you can see what I'm going to do next and why it'll make sense. So what I don't like right now is this negative 1 sitting out the end, so let's distribute y into that. So let's rewrite this as y over 2y minus x times 2y minus x over 1. And I just put it over 1 so you can kind of see what, like I said, is going to happen next here. Minus 2y squared over 2y minus x minus y. And I'll put y over 1 as well. And again, this is all over 2y minus x squared. All right, so what we're gonna do here that's gonna help us out is we kind of did a bit of this when we were doing limits. We don't really like having the fraction up in the numerator like that. So what we'd like to do is multiply by something that, or factor something out. But I think in this case, it'd be easier just to multiply by some factor that's going to get rid of those denominators like that. What I'm going to multiply the top and bottom of this equation by, I'm going to multiply it by 2y minus x. So the top and the bottom, 2y minus x. And the reason why I did that is because 2y minus x, and then this first, you can see this first part here, 2y minus x, that's going to turn into 1, right? So that's going to turn into 1. That's going to cancel with that, you could say. So that one's going to cancel, yeah, with that. And that will end up canceling. And then the top of this, once I'm done, will end up just being y times this. And I'm also going to multiply this top term by the other one, which again is going to cancel the one on the bottom. So it's going to turn out looking a lot nicer on the bottom, right, or on the top of this equation if I do that. So those will cancel if I do that. And then I'm just going to multiply the bottom by this. So that's just going to change the power of that thing by 1, right? Okay, so I still need to, so I multiply by the 2y minus x. It's going to cancel with that one, like I said, it's going to cancel with that one. And it also needs to be multiplied by this term, right? So that's going to end up just having the y multiplied by that. So if I rewrite this all out, what I end up with is y times 2y minus x minus 2y squared, and then the minus and the minus, that was like a plus, right? So plus y, and then it also has to be multiplied by that top term that we did, right? So that top term, so y times 2y minus x. So then we just, oh yeah, and I keep forgetting about that, 2y minus x squared. And now we just got to simplify. So let's write this out. So we've got y times 2y is 2y squared minus xy, and then minus 2y squared plus, this would end up being 2y squared minus xy all over 2y minus x. Oh, and 2y minus x. Crap, I forgot this. This should have been multiplied by this. So that should have been to the 3 now. Because that times that gives it to a power 1 higher. So to the 3. Collecting my like terms, I've got 2y squared. Those cancel. 2 and minus. And then I've got 2y squared again right here. So this ends up being 2y squared. And then minus xy, that's minus 2xy all over 2y minus x cubed. So this question was definitely one of the harder questions that you'll have. This would, if you could show me a question like that, that would definitely be a high level question on a test, let's say. Okay, so I know that's a long video, so I'm going to end that there. Here's your guys' homework questions. It's also on the website there. So I'll see you guys on Friday.